Start, sir.
Good afternoon, everybody. I think this is the third interactive session, and there is one question that I have, which is from Mr. Shoaib. So what he is asking is, what are the symmetry points in band structure? How can we determine these? What are the factors in a system that determine the band structures? So the first part is, what are the symmetry points in band structure? Symmetry points are not dictated by the band structure itself. It's directed and determined by the lattice on which you are doing the band structure. So the symmetry points are basically the points on the Brillouin zone which are high symmetry points. So if you draw your reciprocal lattice, then draw the Brillouin zone, then first Brillouin zone, for example, then you will notice what are the symmetry points, high symmetry points in the Brillouin zone, and those are the symmetry points also of the band structure. So you see, band structure. I mean, band structure is E versus K. So you cannot plot the entire E versus K throughout the Brillouin zone. In principle, you can, but for the sake of plotting and to demonstrate what are the important features of the band structure, you need to go only through the symmetry point. So, for example, gamma to X, X to M, and so on and so forth. Or in three, if there is a third dimension, if it is a 3-dimension, then towards the A point or L point in the Z direction, and so on. So these are all symmetry points in the Brillouin zone, and your band structure is usually plotted along those directions, because you cannot plot over the entire Brillouin zone. And then remember, the many points in the Brillouin zone are symmetrically related to each other. So it will be redundant to plot the E versus K at every point in the Brillouin zone. So, so that's what one does, and that's the band structure you see. Then the question is, how can we determine this? As I said, you just look at the Brillouin zone, and then immediately you can identify what are the symmetry points in the symmetry directions. For example, from gamma point, for example, which is 0, 0, 0 center, towards say to x-axis one end, right, which is like pi. So you can call it x, so gamma x. Then go from x to m, which is pi point. Consider a 2-dimensional band structure, for example, in a square lattice. Then come back from m to gamma. Now there are no other points which are special in that sense. You can see the x point is related to 4 other points. The m point is related to 4 other points, and these directions actually are the directions which cover all the symmetry directions. So that's how you plot the band structure in a system. Now, what are the factors in a system that determine the band structure? Now, this is, of course, a complicated question in the sense that many things can determine the band structure. One is, of course, the underlying lattice. The lattice structure determines the band structure to a large extent. And then, of course, if there are interactions in the system, then you have to somehow take care of these interactions. There are many ways to determine that. And then the number of orbitals that are involved in the band structure calculations, and if there are other crystal symmetries, like for example Jahn-Taylor's, if there is a Jahn-Taylor symmetry, then you have to be careful about it. So all those things go into the into determining the band structure. So it's not easy to tell you what determines the band structure. Everything cannot be listed as such. I mean, in principle, they can all be listed, but there are so many factors that can affect the band structure. Once you know the symmetry of the lattice, then anyway the general symmetry directions are identified, along which you will draw the band structure. And then of course you will you can of course you can do group theory, for example, to find out what are the irreducible representations, and then the bands will be formed accordingly. But the exact nature, the detailed nature of the band structure example in certain directions. If there are magnetic moments in certain sites, all these things determine the band structure. So, I mean, its band structure is basically the E versus K of an electron, and whatever the electron experiences, given the symmetry of the lattice, gets into the band structure. One step forward, one can actually include effect of interactions, Coulomb interactions, electron Coulomb interactions by different techniques, and they also then affect the band structure. Then, of course, there are further techniques which are specific to electronic correlations. The correlation for example, 3D, 4F, the correlation is fairly strong, and there one can do an electronic structure calculation, which is beyond the Kohn-Sham band structure calculation, which again gives the electronic structure, but including the effect of correlation to a large extent. So that's basically the story of electronic structure. Band structure, by band structure, one actually means the electronic structure now. As I said, there are two levels. One is the Kohn-Sham way of doing things, which is what you did in the class, and which tight binding is the simplest one of those. So then, of course, you can put in the exchange correlations and so on and so forth, which gets into the details of band structure. But after that comes the interactions, electron-electron interactions. So there are methods to take care of that. Even for band structure, there are different methods now. So all that affects the nature of the bands, the microscopic nature of the bands. But the general symmetry remains invariant because it is dictated by the symmetry of the underlying lattice. So let's see what other questions are there. Nirbhay Shahi, what is the question? I don't get the question. His name is there, but I can't see the question. Please write your question here. It just says K, capital K. If you are live on YouTube, then I can try to see it there. I can't find it. So is there any other question? Are there YouTube links? Let me see if the YouTube has any live questions. So yeah, there's no live chat yet. Anyway, let me wait for some time. If people come back with questions, we will take up. Somehow Nirvay Shahi's question does not appear in the Excel file. Your question is a bit general, how to become a professor in IITs. Well, it is the standard route by which you become a professor. Do a PhD, become an expert in a subject, do postdoctoral research, have good research background, academic background, and then if you are interested, then apply to IITs in the respective department, and then if you are shortlisted, appear for interview. And then finally, of course, if you are selected, you'll become a professor in IIT. Is it tough to become a professor in IIT? I cannot answer this question because uh, I do not understand what you mean by tough. So something which somebody may feel tough, somebody else may feel easy. So it's a very subjective question, isn't it? Anyway, good luck to you if you are interested. Well, my experience, well, it is 25 years back, so I don't even remember. It was not tough. I don't think it was tough. At least that's how I felt it. It was not tough at all. For me, it was not tough. Okay, fine. I think that's about it. Yeah, I think we should call it a day now. Good luck for your final exams and all that. Thank you so much.
Can we close the session?